And today I would like to talk about the opportunities of using these technologies of large language models in the edtech industry. So I would like to give some context of the period of time we're living at the moment, as today we're living in the fourth education revolution. Let me give you a quick background. What were the other three? So the first one typically is the origin of the Homo sapiens, that was organizing learning communities. Then we had the coming of schools in forms of elite universities, just for the few. The third education revolution was in synchronization with the industrial revolution to meet the demand of the industry. And the challenge we're solving today is how can AI work in concert with teachers to provide this individualized teaching? And this is a very interesting concept, very well explained by this book, if you want to read more about. And let's try to answer that question now. And the most straightforward is, if I'm a student and in the local classroom my teacher is teaching me lessons about photosynthesis, then when I'm home, the teacher is not around, so I could ask ChatGPT or any other language models to, can you help me understanding the concept that I'm studying at school? So this is the most obvious way, like a tutoring session. But there are few challenges, because those language models can be very convincing but very hollow. What I mean is that there are few things they can do very well, like memorizing facts from the internet. They're really good at generating very coherent scripts. So linguistic speaking, they're really good. But there are few things they cannot always do very well, such as they do not always provide accurate facts. They hallucinate. Sometimes they don't know what they're talking about in the specific domain, because those are general purpose models. They're not trained for the specific education or the specific educational subject domain, and they're not individualized. Like, they're going to give the same answer to every user, no matter who is asking. If it's a high school, elementary kid, it's going to give you pretty much the similar answers. So this creates a few challenges in education. So the learning experience can be misleading for the students. If they get wrong answers, that's the most obvious one. But even if we give good answers and we just give the answer to whatever question they ask, they're gonna be very lazy. They're not gonna put enough effort to understand why things work in a certain way. So we need to enable users to derive the solutions themselves, rather than just helping them cheating with homeworks, for example. And that creates gaps between the experience they have in the classroom and what the language model provides. Simply using different language, this can already be a misleading experience, different teaching methods, but very importantly, curriculum connects concepts in a certain order, and if the way I explain you photosynthesis is introducing new concepts, not in your curriculum, this is also misleading. So at Brainly we have identified a few dimensions that we are investing on into making sure that the answers provided by those language models follow those criteria. The first one is, of course, to contextualize on the user intention. So it's not just about the question, but also having larger information about the specific user, what stage of the curriculum they are, to understand what exactly they need. Is it like confirmation of a homework, or is it like, I really don't understand something, I want to learn more about this topic? Of course, factually correct. This is actually obvious, but it's really hard to achieve. How do you measure if the answer is factually correct? It's an open problem. Making sure that the answer provides explanations, not just the final solution. But then very important is to personalize on the specific curriculum. That's very individualized. Each single user, each single classroom, we can say, has a curriculum, and we need to reinforce the same vocabulary. We need to be able to connect the knowledge gaps that the user had throughout the curriculum, and make sure we do not introduce anything which is out of scope or something that is later in the curriculum, not being introduced yet in the classroom. We don't want to move at different speed than what the teacher is teaching, locally. So in order to implement that, this personalized good answers, we have to consider a few paradigms. What I'm going to present now applies to general purpose, but I'm going to show you examples specifically for what it means in education. The most obvious one is, of course, prompt engineering. This sounds trivial, but I can guarantee you that you're gonna have to run a lot of iterations of framing things in a very different ways, and you're gonna see very different results, just the way you frame the problem to your language model. So, for example, as part of the prompt engineering, very common is to use examples. No, this is few-shot prompting, and the choice of examples will make a big difference on the final quality of answer you get out of it. There's a chain of thoughts. This is another paradigm that you need to solve. So if you only care about the solution, you still want to trigger the model to first things in terms of a logical reasoning, what are the steps, and then write the solution. So if you ask the model to write the solution and then the explanation, versus first write the explanation and then write the solution, just by changing the order, you're going to have higher accurate answers, just because now you're forcing the model to first go through this logical reasoning, and then you're asking them, okay, now you derive the answer. This is called chain of thoughts. Sometimes it's not possible to get the final answer, the correct one, the good one, just in one shot. Just prompt, answer. Sometimes you need to repeat, you need to interact. So you want to have this programmatic environment where you take the output of the model and then you re-ask again, by framing in a different ways, by adding a little bit more, by pointing out the things that are wrong about the previous answer, until you converge into the answer you want to return to your users. So this is called prompt steering. Very common, probably all of you have heard. It's fine-tuning, which is about take a base model and then take your set of QA data, can be in the order of a few thousands, and you have your domain personalized, let's say domain-specific model. Now here, I would like to make one distinction. If you pick a base model like a commercial one, say GPT from OpenAI, Cloud from Anthropic, you won't be able to change the weights of the models. So when we talk about fine-tuning for commercial model, we're talking about creating an encoding layers on top, which is equivalent to say, I don't want to spend time into prompt design. I want to show you some examples, and then I'll let the encoding layer figure out how to convert my request to model into the way to ask the model. So you can skip the prompt design, if you do this. But when you go with more open source models like Llama 2, you can actually change the weight. So you can actually inject new knowledge that the model didn't have before. So fine-tuning can take very different shapes depending if it's commercial or not. One pattern that is I'm seeing that almost every company is adopting, because this is proven to reduce hallucination. So if we really want to improve accuracy of your answers, you definitely want to create this integration called retrieval augmentation generation. The simplest form is to run some semantic query on your set of documents and just inject the documents into the as part of the prompt. But you're going to do more. For example, if you have this knowledge base, rather than just searching for documents to inject, you can actually use the LLM to, okay, here's my corpus. Now, can you pre-populate with a bunch of question and answers? So you can prevent the sort of question the users are going to ask about this specific curriculum. And you can use them also for creating quizzes, assessments, things like that. Tools integration is a very also interesting paradigm. Yesterday was a talk by Meta specifically about this. So there are a few limitations that the model can do. Multiplications. Ask a language model to do multiplications and likely they're going to fail. It's a very simple task, but they are language, they're not mathematical models. So in this case, you may want to integrate with some external calculator. It can be Python, can be, there are many calculators, Wolfram Alpha, whatever. Sometimes the model needs to have access to some database, proprietary data. So you may want to use the model for generating the SQL queries to run. And then, or for sometimes you need to get access to up-to-date information. So the model doesn't have up-to-date information, so you need to integrate with a web search. But which kind of web search, which kind of query you run, which kind of Python code you execute, that's something the model can do for you. Then you take the result of this tool integration, then you go into a second request that says, okay, here's the results, now produce the final answer. Um, Knowledge distillation is also a very important paradigm when you're moving into more cost optimization phase, typically. So you start with the big models, big ones that can solve a lot of problems for you. But then you realize that you're only using very tiny fraction of the capacities of the model, very tiny, because you create an endpoint, a microservice, just for solving one problem, and you realize you don't need 500 billion parameters for just solving that. So you can take whatever historical data for that specific task, and you can train a small model that can do as well as the big one just in that specific task. And here there are a lot of techniques like the low rank adaptation, LoRa, model quantization, and those new Llama 2 models and similar kind of models that you can actually use for commercial purposes as well. I hope. I'm going to check again after your talk. But Llama 2, respect to Llama 1, had this difference in legal terms. So this is the knowledge distillation. You want to make sure that both the questions asked by users and the answers are guardrailed. So you want to make sure that user is asking something non-educational, you don't answer. You block that. Say no, this is not appropriate. Sometimes user may ask questions that are not answerable, so there's no answer because there's no question. Of course, spam, toxic, but even things that are not well formatted can be tricky. You may get wrong answer just because of the formatting issue of the question. And same way on the way back, even if the question is high quality, how do I make sure that before I return the answer to the user, I know it's correct, it's complete, the language is user friendly, is it safe? No. Now, if you use some commercial like OpenAI, Anthropic, they implement a lot of those guardrails. It can be pretty safe. They're not going to answer anything that is toxic. It's very safe. It's really hard. I mean, they're making a lot of improvements as well. But for example, when you do knowledge distillation, now you have your model, and how do you make sure this doesn't happen? And if you're serving your model to a user-facing application, then that's a problem you need to solve. And likely for us, language model can act as a judge. So you may have one model for answering, but you can have another model, can be the same family or completely different family of models, that can check, hey, is this question correct? Is this answer produced by this other model actually, have those characteristics? And if you detect any issue, you can also fix it. You can ask that model, okay, now can you please fix for me? So those models are really incredible. You can do a lot of things with them. And this is probably a very beauty paradigm. So I've been spending my whole career, building training sets as a data scientist and building classifiers and all of that. And then you realize that you don't need any of this. So if you need to classify content according to the taxonomy, you don't need to do any data science. Like it's over. It's the end of an era. You just ask, and they are much better than training a data set with labeled data set, a transformer, BERT-based model. Then you compare the quality, the accuracy of the predictions of your model tailored on your data, and just asking, just zero shot, not even one example. And it's incredible. Some of those models, they just do even better. They're your domain-specific model. And you can use that for a lot of other things, traditional NLP problems. They already know how to solve that. And this introduced also this new paradigm, which is language chains. Because you can have specific models solving each specific task, now you can build pipelines. So in this example, I'm showing you two patterns. We see it's called RAG fusion, which is an evolution of the retrieval augmentation generation, where rather than just taking the question, using the question as a query, you have the question, you have a model that produces queries, generate queries. You run your queries, now you retrieve documents. But those documents might be very large, and you can have many of those, as many you want. And how do you include all of those as part of the final answer? You have a limited context window you can specify. Even if you use cloud, which is 100,000 tokens, might still be not enough, who knows. So you summarize those documents, and then you merge those to the final answer. And here I also changed another paradigm, which is the presenter. So you can decouple the generation of the answer from how you want to serve to the end user, more like a client requirements, client UI requirements. So this, and of course, you need to build your own specific quality evaluation framework. You're not going to find this on the internet. This is specific to our domain. So at Brainly, we want answers to be tailored to the curriculum. So we have developed some techniques based on language similarity, topic modeling, keywords analysis, some rules, some manually annotated data set, and we are capable of quantitatively measuring how much one answer is actually close to the curriculum of the user. Now, every user has different curriculums, so you can imagine thousands of those curriculums. So it means for the same question, we may have 1,000 different answers, and each one is tailored for that specific curriculum. So the message I want to deliver here is that, yes, the technology is off the shelf, language models, but if you want to build products with that technology, you cannot just serve it as is. You need to build layers. This is your intellectual property. This is your unique value proposition as an enterprise company. You want to build those layers around that will make the core technology sellable. You can actually building the product out of it. So this is the first part of my talk. Now, quickly, I want to say what is the impact that's going to happen on the job market and the education industry. So first thing is that whether you want or not, whether you work in AI or not, you need to learn how to use those AI tools. You don't have really other choice. This is not just for AI experts. This is for everybody. So if you're a content creator, you really want to make sure that you focus on high quality part of the content by automating all the repetitive tasks. You want to specialize in all of those areas where the AI is not good at. And this is, to me, a very high opportunity. I foresee this to be one of the highly demanded jobs in the market now. Content creators who knows how to leverage those AI tools. When it comes to teacher, again, you can go with the traditional way, fine. But if you integrate that in the classroom, those AI tools will not be replacing any teacher, but they will be supporting your mechanism. Because if you know how to use it, they're going to follow exactly the same teaching style. This is going to give better experience to your students, but it's also going to collect data they can use for individualizing even more how the whole teaching experience in the classroom happens. And of course, for the learners, this is the biggest opportunity. I'm home, teacher is not around. I have an AI tutor that can act like the teacher. Great. That's fantastic. And it's much cheaper than just paying for tutoring, private tutoring sessions. So they can learn fast, they can focus just on the things that matter, and they can really dig deeper into those topics without losing time into figuring out things that they probably don't need to know for the educational goals. And this was also confirmed. This is a survey of students in the United States conducted by Brainly about how they actually use AI. And more than 60% of users, they confirm, yes, we use this AI technology for explaining, answers. And let's also remark what are the opportunities for, I guess, most of us here, I guess, at this conference where most of us are AI experts. I presented a few engineering paradigms. This is just a high overview, but the state of the art is much more complex. So these are all new paradigms that you want to learn. And this is an opportunity. You can build on top of the giant's shoulders. That's, as I showed before, like text classifiers. Really, it's the development, the R&D process is much faster now. And you can also build this positive impact on society. So that's the end of my talk. That's my last message. So this is my motto. I hope you're going to remember that message, which is let the machine do the heavy lifting so we humans can craft the beauty, which machines won't be able to do that. Thank you very much. And if anybody's interested, Brainly is hiring for a bunch of roles in this domain. Thanks. And any questions?
Okay, thank you.